Bismillah ar-Rahman ar-Rahim. Dear students, as you know that we have started a lecture series for object-oriented software engineering, and today in the same sequence we have a lecture regarding interaction diagrams in UML. And one of the most important interaction diagram in the UML models is called sequence diagrams. So we have a good discussion regarding sequence diagrams today, which includes all the important ingredients for the model, why we need sequence diagram, and how we can develop those diagrams in a given situations or in a given scenarios. So we start our discussion regarding sequence diagram with just a little introduction about the interaction diagram. So UML specifies a number of interaction diagrams to model dynamic aspects of the system. So one of the important thing which we have to understand that this model actually captures the dynamic aspect of the system or a dynamic behavior of the system, because it involves communication among the objects, and we all know that whenever we talk about communication, it means that we're talking about object interactions in terms of message passing. So what are the dynamic aspects? Moving messages, moving among objects and classes. As we know, when we talk about object-oriented models, we believe in object interactions. So objects interact with each other, they call each other, they pass messages, the parameters have been passed to the other objects, instructions to be passed. Maybe there is a creation of object, there is a destruction of objects as well. So all these we need to capture when we talk about a sequence diagram. Also the flow of control, the controls definitely will be transferred among the objects, so we'll try to capture that as well, and the sequence of events, which is very important. Normally when we talk about interaction diagrams, there is one which is called sequence diagram, which we will focus today, and there is another interaction diagram within the UML which is called collaboration diagram. So here we are focusing on sequence diagram because we are more interested in also determining the sequence of events, which event occurs first, or which communication occurs first. So this will try to capture in this diagram. So in UML, as you know, there are various dynamic diagrams. First of them is called interaction diagrams, set of objects or rules and the messages that can be passed among them, which we'll see in this lecture. And when we talk about sequence diagram, it means that we emphasize in the time ordering. Here the time ordering does not mean that we are talking about actually in terms of time, but it is basically the ordering, which communication occurs first, what is next, so on and so forth, until that task has been done or that functionality have been created. There are other diagrams as well which also shows the dynamic behavior. One is called state machine diagram and the activity diagram. So obviously these diagrams will be discussed in the later lectures. So what is a sequence diagram? This, as we have discussed earlier, number one, it describes the flow of messages, events and actions between objects. So whenever we have those interactions, that interactions is definitely in terms of messages. There are certain events which will happen, definitely that is the reason why objects call each other, and on the occurring of those events, those object has to interact or take any action, which we will see in the examples. Number two, show concurrent processes and activations. So sequence diagrams are also used to determine the concurrent or the parallel processing among those objects. Means that object call one object, and the same time object may call another object, or object instantiate events at the same time, or transfer controls to the other objects. So it means that we might have concurrent processes and activations show time sequence that are not easily depicted in other diagrams. So no other diagram captures the sequence of activities. Here we have the sequence, so we exactly know which event or which interaction occurs first and how the object replied to it. So we have this information available in the sequence diagram, typically used during analysis and design to document and understand the logical flow of our system, because in the beginning we focus on the use case models to determine the functional requirements, but actually we want to see that how those functional requirements have been achieved, how those objects interacted with each other to complete that particular functionality. So that is elaborated with the help of a sequence diagram. So let's see a very simple example, and then we'll talk about the various ingredients which are important when we talk about a sequence diagram. So here just first example for you, and it is an easy example to understand. So some of the things which you can see in this diagram, which we'll discuss in the next slides as well. On the top you can see the objects. Here the student object, you can see here, you can say that might be an instance of a student, which is an object. There is another object you can see over here that is called seminar, and the interaction captures that how a student enroll for a certain seminar. And the third object here you can see is regarding a course. So there are three objects which are involved in this particular interaction, and you can see here that there are lines, vertical lines against each object. So there are three objects and you can see there are three lines. So that line, dotted line here and here, that represents the lifeline of an object. So that is basically the lifeline of the object. It means that object, how much time that object is involved in a particular interaction basically describes the lifeline of the object, or you can say the timeline of the object. So we can say that this interaction is completed, that is the lifeline of a student, or how long the student is involved in this interaction or a communication, how long the seminar is being involved in that communication, similarly the course. So that is called the lifeline. And here you can see there are various interactions starting from the first one that shows that there is a communication. You can see in terms of an arrow, it means an arrow moving towards seminar, and which says enroll student, and in the bracket you can see a parameter which is called a student, which itself is an object. So that student has a certain identity, that identity has been passed to enroll a student, and as soon as it is received, the next interaction is between the seminar and the course, and here you can see, is the student eligible? So the course will determine whether the eligibility is there in terms of certain criteria, whatever the criteria has been established for enrolling a student for a particular seminar. And after that, that communication is sent back to the student object having certain history, and that historical information has been acknowledged by the student to a course, and then that eligibility status has been sent to the seminar, and now it can be enrolled, and that enrollment status, as you see, has been sent to a student. So in that manner a simple communication is being done. However, that communication is very simple and it does not involve any complex phenomena. For example, if else-if conditions, or there is no multiple loops or even loops in this, and there is no specific conditions which have been involved. So this is a very simple communication, but it shows that there is an interaction among these objects unless that communication has been established. So here you can see this diagram, and here you can see the timeline. Time is increasing. So remember, at the lowest level, whatever the communication you have, it means it is the latest communication. So let's assume that if we have this arrow, the last arrow, it means that that is the latest communication in that scenario. And obviously the first one is this arrow, that is enroll a student. So this is the first communication. So remember, the time is, you see, increasing as you move on. So starting from here, moving on downwards. All lines should be horizontal to indicate instantaneous actions. Additionally, if activity A happens before an activity B, activity A must be before activity A. So if this happens first, this is there, and you can see there is a difference between this communication and this communication, and you can see there is a little gap which shows that this information has been received at this object seminar, and then this communication is being sent to the course. So this is something which we need to understand. So this is the concept of the communication within the sequence model. And okay, here there are some other things which are important, which we need to be considered. As you see in this diagram, that seminar is some sort of a generic object. Later on, that object might be classified as a class as well. Similarly, course is also a generic sort of, you can say, an object. And here we might talk about a specific instance. So here a student might be a specific instance who is actually the initiator of this communication. So we have already discussed in the use case model that there is also a concept of an actor. So actor is someone who initiates the communication, or actors are basically involved in a certain communication. So a student has actually generated this or initiated this communication, and he or she wants to be enrolled for a particular seminar. So that can be regarded as an instance. So therefore it is represented as a student colon student. So here that concept need to be remembered. So again, this line is called, as we have said earlier, is called a lifeline. And you see there is something which is different, and what is the difference? You can see here that in the lifeline there is the dotted line, and then suddenly you see that there is this type of double line against the object. Here you can also see, and here you can also see that this is there. And what is the difference between this and the dotted line? So this is called an activation. So it means that this object is activated, means this object is now part of the communication. A very good example is just like a drama scene. So in recording a drama, we might have various scenes, and in every scene there might be different actors which might be involved, and for how long they are involved in that particular scene basically represents the activation. So there might be an actor who is just involved for the initial interaction, and then there is no communication of that actor among the whole scene or in the whole scene. So the activation is just limited to a certain timeline. Okay, so this represents an activation. Here you can see that the student initiated this communication, so therefore a student is active, and that activation line is started. And when that activation line finished, when that communication is completed and the enrollment status has been given to this particular student as a return call. So here that activation, that is why that this activation is represented in this manner. Similarly, here that activation starts when a message is being generated from the seminar that talking about the eligibility of a student. So that activation is started here, and you see that activation ends here when that code sent the eligibility status to the seminar. So this is the concept of execution as well. So something which is being executed and returned back. So you can see that there are arrows moving from left to right, and similarly there are arrows which are moving right to left. So when we talk about communication, so obviously there are returns as well, so which we normally call message returns. So in this example you can see the lifeline and the execution. So as we talk about return, so you see here that enrollment status is represented as a return call. And normally when we represent a return calls in a communication diagrams, normally we use the dotted line. As you see the dotted line arrow. So that arrow is normally used whenever we are representing return calls. So here also this is a return call, although it is from a student to the course, because the course has asked the student to get the seminar history. So that historical information is needed by a course, and there is a return as a seminar history which is passed on to the course, and on the basis of that there is a return that is called eligibility status, and that eligibility status has evaluated from in the seminar, and then that enrollment status as return call sent to the student. So there are various types of arrows which are used in this diagram, and those arrows are one arrow is the darker one, and the second one is the less darker one, and the third one is the dotted line. So these three different arrows represents three different types of communications or communication messages. One is called the synchronous message. The other one, the less darker arrow represents the asynchronous communication, and the dotted arrow represents the return call. So as we have discussed in various other courses as well, the same concept of asynchronous or synchronous messaging, where whenever two or more objects are involved, either the second object wait for the communication to be end, or it can start the communication with the other objects as well. So that basically differentiates between the synchronous communication versus the asynchronous communication. So here you can see the synchronous message has been sent here from this object student to a seminar, and that's not, and obviously the student and the seminar has this particular type of communication. So that we have to realize that what type of communication is this, whether the both objects have to communicate at the same time or at the different times. So therefore then we can decide for synchronous communication or asynchronous communication, and similarly we represent the same message. And the dotted line, as you see, represents the return call. So here also a very good example of communication, and here you can see that there are four objects. One is called ATM controller, that is a bank, that is a money dispenser, an object which resides within the ATM machine that has the responsibility to find out that particular amount in the dispenser, and obviously to pass on to the user. And the last one is what? The printer, because we need to print out a receipt. So here you can see that communication is being initiated by an actor. So actor is also an object, or you can also say it's an instance rather than the object. So it is an instance who creates that communication, which is called withdraw money. So here, if you remember, when we were talking about use case model, there we have identified in the ATM example, the cash withdrawal is one of the use case. So here we are capturing the communication, that how that withdraw money can be done using an ATM machine. So here the actor initiated the message, which is a withdraw money, to the ATM controller. That ATM controller actually check the balance, and obviously the balance is related to your account. So it means that you have to check the balance, whatever the amount is being entered by the user, and the balance is returned back to the controller. And then that decrement balance amount, obviously that amount will be minused, and my with the amount which is being entered, then that amount will be sent to the money dispenser. And here you can say at the same time there is a print receipt as well, so both the tasks can be done at the same time. And when the printer completes the job, it is done, and when it is done, the card will be ejected, the transaction will be end. So here for you people, we have captured this diagram, but there is something which is lacking in this diagram. So how to understand what is lacking in this diagram? What actually you think that should be there but it is not being represented? Something missing over here might be in this communication. So while we are checking a balance, so let's assume that balance is not greater or equal to the amount which has been entered. For example, a user entered, for example, 10,000, and there is for example, when talk about a balance, there is a 9,500 balance. So what will happen next? So that communication is not being recorded here or not being represented here. Here only there is a check balance, balance is returned, decrement the amount. So there is no certain checks which have been involved here, which checks the amount in the account to proceed for the transaction. So if it is true or yes, so it means a condition may be invoked or a set of conditions may be invoked such that those checks can be involved over here at that particular object, and then decides whether that decrement should be given or that transaction should be declined. So at that particular stage the transaction may be declined. Similarly, that activity might be done at the money dispenser as well. So it means that we have to involve conditions as well, which we'll see later on, that how that we can involve those conditions into the diagram, so that those conditions will be represented while we are designing the system. One thing which I just want to add on here, that is regarding creation of an object. So all those objects which are initially part of the communication are represented at the beginning in this manner. You can see in horizontal line, and then there are vertical lifelines. But if it is also possible that object may be created during the communication, it means that object is not a persistent object. So because it is not a persistent object, so that object might be created between the communication, and there is no need to have that object later on because that is not persistent. So all those objects which have been created can be destroyed as well. So you talk about, we have already had a discussion, and we will have a discussion later on about constructors and destructors. So object can create objects, objects can destroy object as well. So in this, let's suppose a client has an interaction with an ODBC proxy, which is there to connect the client to, for example, for the web application. So here client want to interact with the ODBC, and there we have another object which is not in line with these two objects because it is created during the communication. So you see here the message is passed as a create. So create a transaction, that object is being created. Set actions A, B, C whatsoever, with the values will be sent to the ODBC proxy. That values will be set. So it is committed. It means the connectivity is restored. And when that connectivity is finished, that transaction is no more because that object is being created. So as you see at the end, here it is create, and here there is an instruction which is called destroy, because an object might destroy another object. So here you can see when it is being destroyed. So in the lifeline, at the end of the lifeline, you can see a cross. It means that object is no more because it is only involved in a particular communication. So we just see an example of a communication, and we have identified the problems and the issues. So how we can resolve those issues? So here we have the get balance. Fine, we have the balance. So it means here we have to invoke a condition. So you can see that there is an alt, which is an additional component, where we see the balance is greater or equal to amount, add debit transaction, check number comma account, store photo of a check if there is a check deposit which is being accepted by the ATM, or if not the check or the transaction is electronic transaction without showing a check, even then that condition can be invoked. Similarly, if let's suppose if this is not the case, else condition, where we have an insufficient, let's suppose, fund or a fee, so we have to refund the check, or in case of transaction we have to decline the transaction, so that transaction cannot proceed. So it means that it is very good that in sequence diagrams we can also capture these type of conditions, multiple if else conditions, and we can have a better understanding of the system. So here another example, and here you can see that there are three objects. One is called the registrar office, that is account receivable, and for example that is a class, drama class. So get pass due balance, student I, that balance is being returned. So for example, if the due balance is equal to 0, that message is being sent to the class. Get cost of the class cost is there, which is being returned, and charges for the class. So that communication has been done. So here that box shows another thing which is called an option. So it means in the communication we also look for options. Even in use case models, if you remember, whenever you talk about use cases and use case templates, there also we have the alternative scenarios, alternative situations, because we believe that whenever we're talking about a communication or execution, that is not only the one way scenario, because there are other conditions or scenarios which might happen, and also the exceptions as well. So here that communication you can see is in the box, that is the option. So you might have another option as well. So if this option not works, the other option might work. Last example here you can see, which is a good example because it covers another aspect of the system of the sequence diagram, and that aspect is regarding loop. So we can also include loop into the system. Why? Because in the communication sometime it is possible that the communication is repeating or repetitive communication. So instead of generating multiple messages into the diagram, which makes the diagram more complex or more detailed and more confusing, so rather that model which simplify the system, it may make the system or a model more complex. So therefore in a sequence diagram you can also include loop as well. So in this diagram, if you can see, we have an order object, we have a distributor, we have a regular distributor, and we have a messenger. So you can see the lifeline, this lifeline is here of the order. So starting with the dispatch message, and you can see that there is a loop combined the fragment. Here you can see for each line item. So that order might be in this particular order, maybe there are 120 items are involved. So whether we can generate each message for each item, so it means we have to generate more than 100 messages into the diagram, or we need to make 120 diagrams to represent all those scenarios. So instead of doing this, we have a loop for each line item. So let's suppose it may be 5, it may be 10, it may be 500. Then you can add a condition. If that value is greater than this, then that dispatch will occur. Okay, and else there might be another condition, and in that case the regular distributor will dispatch. So if the value is greater than this, then there is a careful distributor, that dispatch will be done, or if it is obviously less than 10,000, it means that will be dispatched by the regular distributor. Alt condition needs confirmation. If that is being confirmed, then it is passed on to the messenger. So you see that loops can also be included within the sequence model. And if a certain message or a condition or a function or an action which you think go for multiple times, you can also add static to it. So this is a brief description or a brief overview of the sequence models, and you see that sequence model are very beneficial whenever we want to illustrate the dynamic behavior of a system, and obviously to show the interactions among various components, objects, and actor over time. So this gives us a good visual interpretation of the system, and it is very good to interpret what is happening between that communication, find out various behaviors among those objects, and try to depict various operations and methods which are being involved, and try to determine the responsibility of the object as well. And during the design phase of the software development process, sequence diagrams help developers and architects plan and understand how different components object will interact to accomplish specific functionalities, what is their role, which parameters are important, who will do what, who is responsible for what. Sequence diagrams serve as a communication tool. Yeah, it is very important. So if you depict the relationships among the objects, it is very good for you to share it with the users, because it is a standard model. So therefore that standard model can be communicated to everyone, so that has a universal language. So you might interact with the developer, designers, and the project managers rather than the descriptive point of view. Developers use sequence diagram as a debugging tool as well, because it interprets the communication, so it is very easier for us to debug it, to find out what is going wrong among that communication, where is the loophole, where is the problem. We can easily identify the problem as well. And with this, I conclude this lecture. Thank you so much for listening me, and looking forward for your feedback and questions. And also let me know which other lectures you might need, you might think that those have to be covered. And obviously we'll do our best to cover all those lectures. And there are so many other topics and related discussions which we might have in the future. Thank you so much. We'll see you soon for the next lecture.